Okay, welcome guys. Happy 4th of July and welcome to the first video on this channel. This channel is going to deal with a lot of quantitative finance questions that you could be asked in interviews. And it's also just for the love of the game because if I'm being honest, I think that these probability questions, the coding questions, they're all a lot of fun in my opinion. So let's get into it without further ado. So this question is called card game. We're at a casino. We're with a normal deck of cards. I don't feel like I have to explain that. If you don't understand, just read the question. So the cards are shuffled before every attempt of the game, and this is how the game works. We, the player, will pick a card first, and following that, the dealer will pick a card. If the card we pick is a greater number than the dealer's, we win. However, if the dealer picks a card that is the same rank as ours or greater, then the dealer wins. Okay? So let's get into the solving of the question now. Okay, so let's get into the question. Now, when we do these questions, it's important to look at the events. We want to create events and we want to kind of dissect our sample space, okay? So it'd be easy to say something like event one is that we win, you know, and event two is that we lose. But this would be too easy and it doesn't give us a lot of information in order to solve the question. So for that reason, our events need to be more specific. So we're going to use three events. We're going to say event one is that we, and I guess to represent us, I'm just going to write this little scribble guy, okay? We, that's us. We pull a card that's greater than the house, okay? Event two is that we, scribble man, pull a card that's equal to the house. And event three is going to be that we pull a card that's less than the house, okay? So don't you see how these are all the possible options? This is our entire sample space here that we've cut up. We're either pulling a card that's greater than the house, or pulling a card that's less than the house, or pulling a card, we're pulling a card that's equal to the house, or we're pulling a card that's less than the house, okay? All right, so we also know that we go like this, okay? So when we sum up the events, we know they're going to add to 1, okay? So this is to say the probability of event 1 plus the probability of event 2 plus the probability of event 3 is going to equal 1, okay? Okay, let's move on and start solving. So I think we can start by asking ourselves, hey, what's the probability of event 1? Because isn't that what we're trying to solve for? Don't we want to know the probability that we're going to win? So we can't really quantify this off the bat. What we have to do is use some probability solving tools and tricks, okay, from our, toolkit of probability. And the one we're going to use, I'm not sure if you can see it, is symmetry, okay? We're actually going to see and make the observation that event 1 and event 3 are completely symmetric. And I know you might not believe that because we're saying, hey, the house chooses second. Isn't that going to affect something? But guys, it actually does not affect anything, okay? I want you to think about the experiment like this, okay? The reason we have symmetry is because think about our deck of cards, okay? And now just randomly take, I'm sorry, not randomly, but take the two cards off the top of the deck, okay? So this is going to be card 1, and this is going to be card 2, okay? And now think about this. We're going to allow the player to choose which card he wants, okay? This is the exact same thing as the experiment we were already talking about earlier, okay? I'm just framing it differently. So let's say the player chooses this card, okay? Which means that the dealer is going to get this card, okay? Wouldn't you agree that when the player flips his card over and looks at the number, there's a 50-50 shot that this card right here is either going to be larger or it's going to be smaller. And it doesn't depend on what card this is. Say that if the player pulls a king, you might be thinking, hey, but if the player pulls a king, there's a pretty small shot that this is going to be, greater than a king. Guys, if you think about all the possibilities, right? Think about the flip side. Think about a 3. Now there's an equal probability that this is greater than the 3. So when you add up all of those possibilities, you see that it's actually the exact same. It's 50-50 whether or not the house's card here is going to be greater, okay? So now we've proved our symmetry, okay? So I'm just going to move this proof of the symmetry, even though you can't really tell what it is, just like this. Oh, man. Come on, proof. Come on, proof. There you go. I'm going to move it over here, okay? And I want to get back to the good stuff, right? So let's get back to the good stuff. Okay. So now that we have proved our symmetry between event 1 and event 3, we know the probability of event 1 is equal to the probability of event 3, okay? The probability that we pull a card greater than the house is the same as the probability we pull a card less than the house. And for the sake of our argument, we're just going to call this x, okay? And now let's plug in this x over here, okay? So if x is equal to the probability of event 3, and it's also equal to the probability of event 1, and we know that probability of event 1 plus probability of event 2 plus probability of event 3 equals 1, then we're basically saying 2x plus the probability of event 3 is equal to 1. Okay? So let's take a look at this probability of event 3, right? Because this is something that we haven't really examined yet that is going to be really important, okay? So I'm going to scroll down a little bit here, all right? The probability of event 3 is the probability that we pull a card. I'm sorry, that the card we pull and the card the house pulls are exactly alike, okay? So when we pull a card, that's just saying 52 over 52, okay? This is the probability that we pull a card. We are pulling a card, okay? It's any card. The probability of pulling that card is 1. And now the probability that the house pulls the same exact card is now 3 over 51, okay? Because think about it. There are now only 3 remaining cards in the deck of that same rank, and the deck is now of size 51. So this, okay, is the probability that we pull the cards that are the same, okay? So now we have the probability of event 3. So let's go back to our equation. And obviously, this is 1. So the probability of event 3 is really just this 3 over 51. So going back to our equation, right? Take a look at the equation. We said 2x plus the probability of event 3 equals 1. So we're now going to bring that, sorry if that made anyone nauseous, we're going to bring that down here, okay? 2x plus 3 over 51 is equal to 1, okay? So then 2x is equal to 1 minus 3 over 51, which is 48 over 51. And x, okay, x is equal to 48, over 51 divided by 2. Or in other words, x is equal to 48 over 102, which I believe, let's see here, 24 over 51 should be 8 over 17. And this is our final answer. Wow, that should not have happened. This is our final answer, okay? 8 over 17 is our probability of winning, okay? Thanks, guys, for watching. I'll catch you in the next one. I hope this helped. And happy 4th.